Hello everyone, welcome back to mahafarkar.co.in. In this article, we are going to learn about the important property of fluid that is called viscosity. Now, before starting with viscosity, in a standard 11, you have learned about the friction that is produced in the solid. So I will say viscosity is also the friction which is produced in the fluid. So how that friction is produced, that we are going to find out. To find that, suppose that liquid is filled in the container, wide container it is, sufficiently wide container is there. Okay, suppose liquid is filled in the enough wide container such that liquid flows from one phase, liquid is slowly flowing, or suppose this liquid is in the river flowing from the one place to another place. Now, if I consider the individual layers of liquid, what we have learned in the previous article, 1, 2, 3, 4, 5, 6, 7, say n number of layers of liquid are there. Now, if I say velocity of first layer is V1, then why not velocity of second layer should also be V1? लॉजिक लक्षात घ्या, जर पहिल्या लेयरची वेलोसिटी V1 आहे तर दुसऱ्या लेयरची पण V1 का नाही ते तुम्हाला शोधायचं आहे. ते शोधण्यासाठी लॉजिक एकदम सोप्या पद्धतीने अप्लाय करा. अबव फर्स्ट लेयर या पहिल्या लेयरचे जे पार्टिकल आहे त्यांना फ्लो व्हायला अपोज करायला कोण आहे? एअर आहे आणि त्याच्या खालच्या साईडला लिक्विड आहे. बट फॉर द सेकंड लेयर जर हा लेयर इथं फ्लो होतोय तर त्याच्या वरच्या साईडला आहे पुन्हा लिक्विड आणि खालच्या साईडला पुन्हा काय आहे? लिक्विड आहे. सो लिक्विडचा एक लेयर या लेयरवरती अपोज क्रिएट करतोय. सो इफ these are the layers of liquid and they are flowing, then they are getting lateral compression from the both direction. Because of that, we will say some certain force is acting between. This is the first layer and this is second layer and this is third layer. So these are flowing from one end to another end. In that also, they are getting opposed by their individual layers. This first layer is opposing the second, and first layer is get opposed by air also. Because of that, the velocity of that layer is restricted by some means. That ability of liquid in which the relative motion between the layers of liquid is get opposed because of their own neighboring layers is called as what? Viscosity. So what is the viscosity? The property by virtue of which there is an opposition between relative layers of liquid is called as what? Viscosity. The force by which they get opposed with each other is called as viscous force. The force by which the different layers of liquid are get opposed is called as what? Viscous force. So what is viscous force? That force acting normally to the given surface of fluid is called as which force? Viscous force. It is nothing but the frictional force. It is nothing but what? Frictional force in a liquid or fluid. It is the frictional force in a liquid. Why I am telling fluid? Because fluid consisting of liquid plus gases. So when gas flows, this force will also act, and so that they get opposed each other. So viscosity is the property which helps liquid to flow in a certain restriction, and because of that there is a restrictions of flow for the types of the flow, what we have learned already, like streamline flow and turbulent flow. Because of that ability of viscosity, we got two types of flow, that is what? Streamline as well as what? Turbulent. Now when we discuss the liquid, one important term is always used to discuss, called as velocity gradient. It is called as what? Velocity gradient. Now to discuss this velocity gradient, we have to consider some important thing. Suppose I consider this layer, I concentrated on the second layer. Say the velocity of the second layer is V. Velocity of the second layer of flow is the V. Now here I consider this velocity gradient we are going to strictly relate with which type of flow? Streamline flow. Why we cannot relate this with the turbulent flow? Because we cannot say there are fixed layers. Okay, so it is strictly studied or applicable for streamline flow. It is strictly okay. Now, if I say distance of that layer from the layer which is present at the bottom is x. So distance, this distance is what? X. Okay. Now, the layer above this one layer will have more velocity. Say velocity of the layer above this one is slightly greater than value dv. So final velocity of this layer will be v plus dv. So correspondingly, distance is also increasing, no? So say distance is also increased by value x plus dx. Similarly, if I consider this layer, then for this layer, distance is say x minus dx and corresponding velocity is what? V minus dx. Are you getting what I said? So if these are the different layers of the flow, then if this is the layer with velocity v and at distance x, then this layer will have velocity v plus dv, slightly more than the first, and the distance is x minus dx. Sorry, x plus dx. Whereas for this layer, velocity will be v minus dv. It will be slightly less than the second layer, and distance is what? X minus dx. So now, if I found change in the velocity with respect to these two layers, layer number 1 and layer number 2, change in velocity, then how to find? Equal to final minus initial. So it is v plus dv minus v. With respect to change in the distance, change in distance is what? X plus dx minus x. So it is what? Dv, and this is what? Dx. Okay. Say this is with respect to 1 and 2, na? This we have found out for what? Layer 1 and 2. If I found for layer 2 and 3 also, see now, what is delta v, that is change in velocity? This minus this. So v minus dv minus v, that is equals to minus dv, and delta x, x minus dx minus x equal to minus dx. So if I take ratio of change in the velocity per unit, change in the distance of layer, this ratio is always constant, and that constant ratio is called as velocity gradient. That constant ratio is called as what? Velocity gradient. Okay. So for every given fluid, for all the different layers, if these are the layers which are moving with different velocities, but for all the layers, delta v per unit delta x, or you can write dv upon dx, for all the consecutive layer is always what? Constant, and this constant value for that given liquid or given fluid is called as what? Velocity gradient. Therefore, I will say velocity gradient is equals to dv upon dx. Velocity gradient is equals to what? Rate of change of velocity per unit rate of change of distance. Okay. Change in the velocity per unit change in the distance is called as what? The velocity gradient. So what will be the SI unit? Just check out, it's very simple. Velocity means what? Meter per second divided by distance means meter. So it will be like 1 upon second or per second. Okay. What will be the dimensions then? Meter per second upon meter. Meter get cancelled, only second will be remain. Dimensions will be what? Only time is there. So 1 upon time means m0, l0 and t minus 1 will be the dimensions of velocity gradient. This velocity gradient is very important factor to study, like what you have learned in the 10th standard, 11th standard for temperature gradient. Difference between two temperatures between 2 points divided by the distance between that 2 points is always constant, and that again completely depends upon the property of flow, heat flow. Here it is depends on the property of flow of fluid. This velocity gradient plays very important role to explain the property of flow of fluid. I hope you understood this article also. It is the small article and you have to go through the article in detail. Thanks for watching mahasarkar.co.in. Have a nice day.